Hello everyone, welcome back. Here we are in our course of artificial intelligence and we are talking about the adversarial search algorithm. So we have been talking about the game playing and adversarial search, and so far we have cast the sequential two-player game adversarial as min-max search task. And moreover, we have said that look, we cannot search the min-max algorithm till the very end. And moreover, the min-max is very slow. So in order to speed it up, we have talked about the alpha beta pruning algorithm, which will effectively double the depth of the search that we can visit the best case. But that is not sufficient either, because we cannot go to the end of the game, and that is because the game are long and the total number of steps that our game may take is very large. So eventually we need to stop the search somewhere in the middle, and we have stopped the search somewhere in the middle, and we need to figure out what is the value of the current cutoff point that we are able to backtrack. All backup update, and that particularly value evaluation function is a key of the graph game playing in some ways. So if we have a really good evaluation function, we need not to do any search whatsoever. We know exactly which move is the best based on just looking at, if I took this section, my evaluation function say you will get this value. If I took this section, my evaluation function will get this value. So let me not even do my search. Let me just do one step, look ahead, figure it out whether this is the best section or not, and I should take. But of course, typically the evaluation function do not get that where that good, and so we need to do some search, but then we have to do cutoff. And when we do cutoff, I need to define or decide the value of that point, and that is computed by machine learning. And the machine learning generally is the idea that machine can learn based on experience or a data. And in this case, data can be historical game that have been played for this particular game between two players, or it could be your own experience that you are playing against yourself. You win or you lose. You back up the values and then you give up your all things agent to your opponent and you start moving again. And this is a sort of what standard machine learning algorithm is doing. Now, many other ideas come together in making good chess player. So now what we are going to see is about the history of cumulative ideas to develop the chess in AI. The chess, as we all know, was one of the most important games to demonstrate the machine has intelligence. In fact, the history is not just 50, 70 years old. The history dates like really very old. If you talk about mechanical truck, it was a fat chess player. There was a man sitting inside a big box who was playing a chess. So the story is like that. Back to late 1700s, yes, actually, I think it is in the Europe where they created a very elaborated mechanism so that nobody could find it, and there could be a human sitting inside, and this human had very short height, and because of which he could squeeze inside the box. And there was an elaborate gadgetry that somebody opens the door, it looked like just some, gears and kind of some mechanical movement, and the things are there. There is a powerful magnet such that this player could play the game sitting inside. So this player was Turkish, and the secret was revealed of particular gadgets and known as mechanical truck. So this particular idea is that you think that machine is playing. So what would happen? This magician or the person will take this in this box to say that I have made a machine which can play the chess, and people will be like course that it possibly, so there will be a game of chess with a machine, and machine will win because truck actually know how to play the good game of the chess. At the end it is a mechanical device that is playing a game. So eventually mechanical truck started, we call a general world of phenomena where you want machine to do something, but eventually at the back the human is doing it. But behind the machine there is a human sometimes, and this human actually does the labeling. And now this is not a secret, everyone knows that the human is a great, and was one such market space, the Amazon mechanical truck. The whole phenomenon comes into this from the crowdsourcing, that you do not know who is doing the task. Somebody from the crowd is doing the task, but somebody is doing it, and that is what we talk about, the crowdsourcing. Suppose you have some questions and crowd gives the answer. In fact, crowd can come in and say no, this answer is correct, this is incorrect, it will cut, it will improve it, it will edit it, and you will get the better answer. So another famous example of crowdsourcing is Wikipedia. So this is all outsourced mechanism. The quality control is crowdsourced. The originating sourcing of the article is crowdsourced. The event occurs quickly. It gets onto the Wikipedia because it is a crowdsource. If there was a person responsible for the article, was always editing it, and you dependent on that person which actually do the editing and do the skeleton. So when the crowds come together, a very interesting and nice properties come in the technology. Because of the history of mechanical truck and the history of chess, another important game for the intelligence had been allowed. And I also told you that even from the very beginning, when the word AI was coined in the field started, people were trying to play chess. And of course, min max come very quickly. It is theoretical understanding of how to even go about modeling a game that come in a pretty quickly. And in fact, the Samuel checker for the program talked about the evaluation function learning very quickly, because you could not go to the very end. You always had to figure out what to do in the middle. And the machine idea of the machine learning comes very quickly. But then the other ideas stick to sometimes to come in. For example, alpha beta search comes in 1966. So you can see in min-max and evaluation functionality comes in 1950, and the alpha beta search comes in 1966. It took around 10 to 15 years for somebody to recognize that you can actually keep bounds and so reduce the amount of search that we need to do. Then the idea of transposition table become very important in the chess, which comes in 1967. For example, I make move 1, you make move 2, I make move 3, and you make move 4. That is a possible and equally possible. Often possible is that I make move 3, you make move 1, and I make move 1, you make move 4. We'll get to the some point. Like this, I move a pawn and you move something, and it goes in a reverse order. So the game remains in the same state. So in games, I can actually go back and forth. So those kinds of cycles are actually extremely common in a game. And we know that when we do research, then for each path, for reaching a node, we are creating a new node. For each path, through each abort position, we are creating a new node. And that is not very good. It is very scalable. So the idea that we can store some memory, do some duplication detection in 1967, and that in that context of the game we call the transposition table. Basically, if two board position are the same, let's not create a new node for it, and let's just keep that in one memory state and maintain the evolution function and best action to do that separately. Then the idea of identity of the deepening comes into the another 8 years to commit, so that iterative deepening, the depth first search algorithms come, that is in 1975. You will go one step, then you will go second step search, you will go third step search, and you will reorder your children based on the search that you read in the previous iteration. Then many other ideas started coming in 80s, and some ideas where you know the end game database and the opening database. One move may be so good that you can always look at the singular extension. Then when bigger supercomputers started to happen, then the idea of the search can happen in parallel. And we do not have to do in one CPU, we can do in supercomputer. So when all such ideas started to come together, the chess player started becoming better and better. In fact, Deep Blue player is a really, if you think about it. So now we talk about little bit what is opening database, what is ending database, and what is middle. If some combination of, so initially it would be an opening database. For the first 20 each position, it is sort of known what to do. There is few strategy that it will follow and will follow those strategies. It may knows that what move to do, and based on what you do, it does not have to do such in sort what knows what to do. Those are best practices in the field of chess. You sort of know how to opening the work. Towards very end, actually, you can pre-compute all the database, all possible games. Let's say all the possible games of 5 and 6 pieces. That is not a large number. Let's say I have a king, a bishop, and one more two pieces in the end game, and you put them randomly in the chessboard, and then you create a database are known as the ending game database, because we randomly place them differently, and let's see how your end, how the end game is look like. And I say then you can take another combination of 4 and 5 pieces, and let us see who wins. So when the game is at very end, you can completely search. You do not need evolution function at the end time. You have been completely searched for the game, because now your number of steps is not very much, and so then you completely search if you can figure out who is going to win. So now it is like this, that in the beginning I know what to do sort of, and at the end what to do sort of, because I have pre-computed it, I have memorized it, I have stored into the database of the opening database and the end database. But the actual worry and question comes, what do I do in the middle is very complicated, because what I do in the middle, there so many difficult kinds of middle position, and game is really far away to finish. So it takes, it is like I'm talking about a lot of look ahead and lot of starting point, and I cannot store them into a database. And there people use all the tricks that you had to min max, alpha beta pruning, evolution function, transposition table, iterative deepening, singular extension, and so on. So everything, all these intelligent things comes in the middle part. So basically chess got divided into three steps: the opening stage, the the middle stage and the end stage. The opening stage was clear what to do. End stage was pre-computer and clear what to do. The magic happened in the middle stage. And as you think little bit, you realize that the phenomena is actually really valued. The valuable for people also who are in the race. Just think about it. Just say, let us say we are talking about a 2 kilometer marathon or half-kilometer marathon race. When the buzzer goes and you start, you have lots of excitement and you will have lots of energy because you are just starting out and you know there is a patient. I want to finish this and I want to win this, whatever it is. Now, when you see the finish line some distance away, then you pull all your efforts into it, and you will say, you will you see that that is the end, and you give all the energy. But when you see that that is not end, I have to go full throat, and somehow it is as fast as I can get motivated to get that. In the middle is what differentiates the successful from not, because in the middle it is very hard to maintain motivation. There is no end sight. You have been running from so long time, you don't know how much you have to run. You don't know whether you are going to make it or not. There are lots of questions, there is so much confusion, and there is so much insecurity. That is when you need maximum amount of intelligence, and you need somehow say we will keep going. At least in marathon you know which direction you have to go, but suppose you didn't know what where goal is it, then it will make up very complicated. So everyone using opening game database, in the end game everyone using the end game database. It is only the middle you have to do the search of things. You are using the evaluation function. You have to learn from the experience. That is where you figure out whether you are good player or not a very good place. So always keep that middle stage is very important stage. Now let's see another, see some other problem. When we do the middle game search, when we do this min-max search, one of the problem with depth first search. So we are always saying we will go 8 plies or a 6 plies or 10 plies, then we'll stop. Now there is a problem here. The problem is what we are only looking at the move ahead. It is possible that we are not able to observe the catastrophic that is going to happen just one move later or just two moves later. It is possible that we think of example, a black can give many consecutive checks before the white explodes. So black thinks, yes, I can kill the king or white, but I can search further, then I can come with some another result. So it happen in the both direction. A move may look good because I have looked at only a limited amount of time, and then it may turn out to be a bad, or move may look bad, but if I had looked little longer, I would have found that yes, I actually was able to know, do check, mat, or whatever. And this is called the origin effect. So what origin effect you can see, suppose you have did the cutoff of the search. So you can see from here that if you choose this path, you will lose the queen. If you choose this path, you will lose the pawn. So what you will choose, you will choose to go here. But if there is no cutoff and you will choose this path, in the next move you are going to lose the queen. So what happened? by choosing a right path, you are going to choose both the things, the queen and the pawn. In the left, you are just going to lose the queen. So the cutoff line, the C, known as a origin effect. So it is another level of intelligence between a people is how far they are able to look and think. I'm not talking about the astrologer. Somebody is able to anticipate that if I make this action, then this person will get happy, this person will get unhappy, and this, if I do this action, and this is going to be work. So it is about how far you will think. So that's why it is known as a origin effect. If you look at till here, then you may lose, because as much you will look deeper, you will get the better result. And this long chain of how what consequences are going to be, we normally are not able to think about, but some people are able to think about that what movies are made of, and how far you are able to look into the future, determine how is the intelligent you are. So this is called origin effect. And how far you are able to look into the future, and therefore what action you do, and so what you do, mean of course the origin effect will always happen, because we are always going to search to some specific depth. So this effect is always there. Now the question, how can we mitigate this, and what can we do to reduce the effect of origin? And this is what we call, one thing called secondary search, and another is Quiescence search. So first we're talking about the secondary search. The secondary search is all sort of saying, look, I think this is a good part to go to this depth, but maybe it is not. Let me verify it. How do I verify it? I just play a game a little longer from the point onwards and just develop the particular path. And if that particular path still looks good, then then we go to that particular path, and suddenly start looking bad, and then we was something was going wrong. I figure it out that it is going to be a go along, and let me backtrack and figure it out some another path which gives me the good result, and that is we call secondary search. So basically in secondary search we just go further and we check whether it will give me the good result or not. Again, there is a origin effect, but we can avoid by just looking one more steps or one more depth ahead. There is another search, that is what we call the Quiescence search. Basically what it say is that some more position are two dynamics. Like I have just given a check, I do not know if the king is going to save itself or not. I don't know whether it is very complicated position, because I don't know what has happened. I have come some level of stability, and I have not idea. So this is called the level of stability in the context of the gameplay is the called question. So I have a secondary procedure which figure out whether this board position will call a stable or not. If the board position will not be a stable, I will not cut off. I will keep going until I will get the stable position. So I will do unequal search. So in one part of action, I may go to the search of depth 6. In another part, because in the depth 6, I got unstable position. So I have keep moving, and I will go to the depth of 10 to get the stable or question position, and I will backtrack it. So a slide says this involves searching past the terminal state. Uh, this involves searching past the terminal search nodes of depth 0 and testing all the non-constant or violent moves until the situation becomes calm, and only then apply the evaluator function. Enables programmer to detect long capture sequences and calculate whether or not they are worth initiating or not. Expand search to avoid evaluating a position where the tactical discussion is in the progress. This expand have lots of things to be happy. Now we will see about how AlphaGo game is it. So it is a combination of deep neural network and tree search, but not of min-max variety. Sampling with tree search. So instead of going through the full subtree, it will sample out some part of subtree, and it will do it intelligently, and it will go do it again and again, and that is called the Monte Carlo search tree. And this is Monte Carlo is a sampling idea in the context of the search tree, which will give the better result, where it is used a combination of deep neural network and Monte Carlo search for the sampling purpose. Then we talked about game search. This is the last algorithm what we are going to talk about. So life is not very different if I have a game of chance. So if I have a game of chance, what I need to do is that not only I have mean and max, but have a chance in the middle. Like I have a lower a dice, I have a six different things can happen. So if you think about, you will have a max node, you will have a min node, but you will also have a chance node, which determine the different things can happen with different probabilities. And if you control, you will control will be a max node. In opponent control we will mean node, but in natural control there will be a chance. So now you are playing a game against the opponent, but you know the chance is coming in the middle, and what you do there is you don't do min max, because you cannot, you have to figure out what to do with the chance node. Let us quickly we see the example of it. So let's say uh, we have the value called 3542, and this is a chance node, and the probability of this is 0.6, this is 0.4, this is 0.7, and this is 0.3. So now if there is a no chance node, we directly take this. If we want to select the max node over here, we directly take the 5 and we do the calculation. But as we have a chance node, the function will come like 0.6 into 5 plus 0.4 into 5, which is coming like 3 plus 2, which is 5. So we get 5 value over here, and this will come, this node will come 0.7 into 4 plus 0.3 into 2, which will come approximate 2.8 plus 0.6, that is 3.4. So we get the value 3.4, and it will choose the minimum value from it now. So this is how it will select. Okay, so this is how the game search algorithm works. So here the chance of probability will play the major role. Now we are end of the lectures, but we'll do the summary over here. So what we have studied in the all the adversarial search algorithm, I think they are kind of this lead us to the end of lectures, and game have been fun to work on the AI researchers. You know, AI researchers are really interested in They love games. In general, people love the game, and if you can play a games for living, is that great life. They illustrated several important points about AI, how to do search in a depth. How do you cut off the search? What you do at the time of cutoff, what different technique can be used to extend the search in variable fashion. The idea of meta reasoning, how much to spend the time for thinking and how much to spend the time for acting. It is exposed that perfection is unattainable. Optimality is a luxury. We always have to do approximation and select is approximate but still get to a good solution and beat the next best thing that exists. That is insight that we get from the gameplay. And the game playing programs have traditionally shown the world what AI can do, and this is now changing because it is more about medical diagnosis and more about using AI for this and other. But traditionally, game have been one vehicle by which AI researchers have demonstrated the success in the field. So we stop here and thank you all.